Today, I am going to tell you about such a metal as zinc. Zinc is one of the transition metals belonging to group 12 of the periodic table of chemical elements. Because of its activity, it began to be extracted only in the 14th century in India. Before that, zinc almost always occurred in many bronzes. In other words, copper alloys. In nature, it occurs in many minerals, for instance in sphalerite or zinc sulfide and willemite. Zinc obtained through electrolysis is quite pure. My zinc was granulated. Granulated zinc is quite easy to melt down because the melting point of zinc is just 419 degrees Celsius. Once hardened, zinc is a solid and dense metal. For instance, thanks to such properties, zinc is used to make lighter cases, hangers, door handles, and so on. However, items made from zinc have a disadvantage, which is their fragility. For instance, zinc hangers easily break down because of the poor viscosity of the metal. If you use high purity zinc to melt such pieces and then you bend them, you will be able to hear such an unusual crack. Such cracks are caused by the deformation of the crystals within the metal itself. As I mentioned earlier, zinc is a quite active metal following aluminum in the reactivity series. Zinc actively reacts with hydrochloric acid, releasing a lot of hydrogen and forming zinc chloride. However, zinc can also react with alkali. I am adding zinc powder to the sodium hydroxide heated to 70 degrees Celsius. The reaction releases hydrogen and forms sodium zincate, a complex compound of zinc. Its compounds, like aluminum compounds, have amphoteric properties. That is, the ability to react both with acids and with alkali. Here is a logical question. How are the compounds concerned if the metal itself dissolves in water, a simple substance? I decided to take the trouble to explain you this matter. The thing is, zinc doesn't react with alkali directly, but it does with water. In regular conditions, zinc particles are covered in thick oxide coating protecting metal from further oxidation. When zinc powder is mixed with heated alkali, sodium hydroxide starts to dissolve the oxide layer on the surface of zinc, and the hot water that is in the solution starts to oxidize zinc. Since water is a very weak acid, it is still strong enough for zinc to be reduced by hydrogen from water molecules. It forms zinc hydroxide that immediately dissolves in the alkali. As simple as that. By the way, you can conduct an interesting copper coins galvanization reaction with the obtained sodium zincate. I removed oxides from the coins in sodium chloride beforehand. I am submerging clean set copper coins in the heated sodium zincate solution. The coins are almost immediately being covered in zinc layer. That happens because of the difference in electronegativity between copper and zinc. More electronegative ions of zinc always stick to less electronegative ions of copper. However, if such galvanized coins are heated, this will cause diffusion of zinc into copper. As a result, brass forms on the surface of the coins, which has golden color and looks like gold. Such an experiment is ideal for pranking your friends by making them believe these are indeed gold coins. Zinc powder also reacts well with sulfur, forming zinc sulfide. As can be seen, the flame is of a green color. That is so because of the zinc ions. By the way, pure zinc sulfide obtained in laboratory conditions can be used as luminophore that glows in the dark on the tips of the clock's hands. If zinc powder is set on fire, it will burn well with the same blue and green flames, forming zinc oxide. Thanks to the fact that zinc powder loses electrons that is oxidizes, it is used as anode in zinc manganese dioxide batteries that nowadays are among the cheapest and the most widespread ones. Nowadays, zinc is more frequently used as coating for iron items because when zinc and iron react, they form galvanic couple. it starts protecting iron, giving out its electrons and thus oxidizing. Zinc is applied to the surface of iron in an electrochemical way. In theory, if a zinc bar is attached to the bottom of a car, making sure that iron and zinc come into physical contact, the iron case of the car won't rust until zinc is oxidized. I think this might have given you some food for thought. Zinc also plays a vital biological role. It engages in more than 100 enzymatic reactions in the human body. It also helps maintain healthy testosterone levels in the organism. Maintaining a healthy level of zinc also helps male reproductive systems to work properly. By the way, scientists recently found out that upon fertilization, a real light flash occurs which is caused by the atoms of zinc. As a result, zinc can be called one of the most useful metals in our life. Besides, it's got great potential to be used in the future.
I'm very thankful for your attention in this video. If you like my new voice actor, please write in the comments what do you think about the new narrator. And also, if you like this video, please give it a thumbs up and subscribe to my channel to see many more new and interesting.